Thank you, everyone, for attending ADISRA's webinar. We're going to begin. First of all, this session is called Designing for Productivity, Advanced Features in ADISRA SmartView. Good morning, and thank you for joining us today. Today's session is focused on the designing for productivity, specifically how advanced features in ADISRA SmartView help you build applications faster, scale more efficiently, and reduce long-term engineering effort. We're going to move beyond just features and really talk about how to design systems that work better from the start. So I am your moderator. My name is Marcia Gabois, and I have the privilege of serving as the general manager of ADISRA. Over the years, I've worked across multiple areas of software, from artificial intelligence to industrial automation, and I have had the opportunity to work closely with customers and partners solving real-world challenges. Today, I will be moderating the session and helping frame the discussion around what productivity means when using ADISRA SmartView. I have the pleasure today to introduce today's presenter. It's Leandro. Leandro leads customer applications and services at ADISRA and brings nearly 2 decades of hands-on experience in industrial automation. What makes this session particularly valuable is that Leandro brings real-world project experience across industries like oil and gas, energy, water, and manufacturing. So everything you'll see today is really grounded in practical applications that he has been using. Just to go over today's agenda, so you know, let me walk through it. What we're going to cover today, we'll start with the architecture because it's the foundation of everything we're building. From there, we will move into the template reusable designs and how can you dramatically reduce engineering effort by designing once and reusing across projects. We'll then look at user-defined data types and how structure drives scalability, followed by runtime configuration, where you can make changes without going back into engineering. Next, we will cover the rule-based system, which brings intelligence into your application, along with triggers and services for event-driven execution. We will also highlight system functions that save time behind the scenes and finish with graphics, screen tags, and generic screens to accelerate the UI development. And throughout the session, the focus is simple: how all the capabilities come together to improve productivity. And we really want this to be interactive. So please let us know any questions you might have. Okay, hold on one moment. I'm just trying to, there we go. I apologize for having some technical difficulties. Hold on one moment and I will resolve them. Okay. Just to start out with our vision, and I wanted just to cover this real quick. Our vision is ADISRA was to transform raw operational data, not just into visualization like most HMI SCADA and alarms and trends and recipes, but into intelligence, insights, and foresight. More traditional systems just focus on that visualization, reporting, alarms, trends, recipe. We wanted to be able to take that data and really build intelligence into it. And as our product evolves, you'll see more intelligence being built into the product. But the next step is helping systems really understand what happened, anticipate issues, and guide decisions. We're focused on delivering that capability in a way that is practical, especially for OEMs, mid-market customer, manufacturer, machine builder, system integrators, without the complexity typically associated with enterprise solutions. So we're really trying to offer a simple solution to not only do HMI SCADA, but build intelligence in as well. This slide just shows how our products fit together. We're going to only focus on the ADISRA SmartView, but you can see here that we have other products available. ADISRA RapidView enables HMI development, especially for OEMs that want application. It's built in the runtime environment. It's template based. It's very much allows you to not go into the development environment if you wanted to build an HMI screen. ADISRA SmartView is what we're going to cover today. It is an HMI SCADA with built-in rule-based expert system and machine learning. InsightView extends to analytics such as OEE, six major losses, and energy management. And then finally, KnowledgeView. It also does predictive and prescriptive intelligence. InsightView and KnowledgeView are cloud-based products. The other two are on-premise. But together you can see it creates a clear path from visualization to intelligence to data-driven operation, and it actually helps customer on their journey to doing the analytics. Just real quickly, ADISRA SmartView is really at the center of our strategy. It is not just an HMI SCADA platform, it really is an intelligence industrial platform. It does combine visualization controls, embedded intelligence, and it can be deployed across edge devices, industrial panels, full-scale system, and even the cloud. This flexibility is actually key to how we think people will be doing more hybrid systems in the future. So with that context, let's walk through what we're going to cover. Let's just talk about some of the capabilities. We'll focus on key capabilities that directly impact productivity, from architecture and templates to runtime flexibility and built-in intelligence, and more importantly, how these features work together. Just to let you know a little bit of our differentiation, I think when we see our products, the differentiations are really the runtime configuration and the templating capability. I need more coffee. I can't even talk. That is what enables faster deployments and easier updates. The built-in rule-based expert system allows you to add intelligence without needing external AI tools. One of the interesting things is why we started out with the rule-based system is because it's very visual and allows people to build the rules, and it will be the guardrail for our machine learning as we evolve the product. So our machine learning roadmap does ensure that the platform continues to evolve into the future. And finally, our scalable design, so you can build once and reuse across projects. Now I'm going to turn it over to our presenter to show you all this functionality. Please keep this interactive. I will try my best to keep up with your questions, and we'll go from there. I'm going to turn it over to Leandro. Leandro, it's yours. I'll stop sharing. There you go.
Hello,
Leandro?
everyone. Yes,
Okay.
yes, yes. I
Okay.
will just share my screen. Just a moment. I think that you can see it, right?
Yes, we can see it now. Thank you.
Okay. As we said, we are going to start talking about our architecture, right? ADISRA SmartView has a modular architecture. We use a modular architecture designed to provide flexibility, scalability, and efficiency application deployment across different environments. The platform is organized into different modules, which represents for a specific part of the system. Okay. The engineering environment, it's this one, right? It's where developers can create and configure the application. It includes the screens, the tags, the templates, alarms, trends, scripts, database connections, and communication drivers. The engineering environment provides a centralized workspace for building and maintaining the entire SCADA application. It is Windows only, okay, and from it you can deploy locally or remotely application. That is the runtime module. The runtime module, it's multi-platform. It runs on Linux and on Windows, okay? And it's responsible for executing the application in real time. It manages the data acquisition, communication with PLC and devices, alarm process, historical data, scripts, and some in the updates, and all the core of our application runs on the runtime. Okay. Also, we have the viewer. The viewer is another a module that the operators can interact with the application. Here is where it displays the screens, the alarm objects, the trains, the events, the dashboards, all the live information. And so it runs locally or remotely. And this is the Windows viewer that is a thin client that you also can have the security part that you can avoid some users to access part of the application or do some actions and everything else. And even if you don't want to the operators to access the Windows screens or something, we have all these features that it's possible running on the viewer. That's unfortunately with the web browser is not possible because the web browser doesn't allow us to insert this kind of blockers. Okay. About the web viewer, the web viewer is for remote access. Of course, you can also run locally. For the Linux, as we don't have the thin client viewer, we have a viewer that runs on Linux that is a web viewer embedded. So if you are running an application on Linux, you need to save the screens as HTML. And if you are running the viewer locally, it's the HTML files embedded. Okay. So this is important, especially for administrations that wants to see part of the the contest or some indicators or KPIs or something like that. So it's important to have a web viewer as well in your architecture. And also the mobile viewer uh, that is also embedded HTML files. So this improves operational flexibility, allow operators, supervisors, and maintenance teams to access important process information remotely and not only on a desktop or in a PC. Yeah, you can have this everywhere. All right. So if you have any questions about our architecture, you can leave a question on our chat, please. Okay.
There is a
Now,
question. Just give me 1 minute. Sorry, not to
mhm.
unmute. On Windows Server, we have all these features and we have some limitations. Or do we have,
No,
okay, on
Windows
Windows
Server,
servers.
no. Oh,
Okay.
no. It's
I think I said,
all Windows. Yeah.
okay. So the question was, just to be clear, obviously need more coffee. On Windows servers, we have all these features or we have some limitations. You said no, we have all the features on
All
Windows
the
server.
features.
Okay.
Yes.
Please continue asking questions. I will be moderating it.
All right. Oh, okay. Blocking the. So now I'm going to talk about the ISA 101 and modern HMI design. One of the most important concepts in modern industrial application development is the ISA 101, Standard for Human Machine Interface. It was created to help engineers design HMI and SCADA systems that improve operator awareness, reduce human errors, and create more effective industrial interface. Traditionally, many industrial applications focus heavily on graphics and animation, often resulting in screens filled with excessive colors, complex visual, and too much information displayed at the same time. While visually impressive, this interface could make it harder for operators to quickly identify abnormal conditions or critical process issues. So it means like if sometimes you develop a 3D screen with a lot of colors and like it makes difficult to get quickly what is wrong, or especially for some like electrical or some that you need to be quickly to response to alarm or something like that. It's better if you have more cleaner design, and it's better for the how do I say, the operator attention, right? So the goal is to present information clearly, consistently, and efficiently so operators can immediately understand what is normal, what requires attention, and what is critical. Okay. What is the principles? Some important is a 101 concept include consistent navigation and screen layout, situational awareness focused design, proper alarm prioritization, reduce visual clutter, limited use of color, high performance GMI concepts, uh, hierarchical screen organization, standardized object behavior, and context-driven information present. So, for example, gray or neutral tones for normal operation, yellow for warnings, and red for alarms or critical shutdown conditions. This dramatically improves operator awareness during the abnormal situation. Here I'm going to give an example. For example, you can use the gray for neutral. You can use maybe yellow for warning or orange. And also you can use red for alarms. You can use the red for when it's running. So you can, and what is important, for example, in ADISRA SmartView, that you can create a template that for all that it, for example, for the status, you just set the values that represents each one of this image, and create a template for the image. Just put the alarm or the tag that represents that image, and then automatically we will show the image without having to work with visibility and a lot of things, because it's a embedded feature that we have. And then it's easier also to export to another project, and then has build your own templates library, and it will make easier and quicker to develop the application, right? So this Smart View provides several features to help developers implement this concept. Okay, using reusable templates, structure objects, dynamic visualization, alarm management, and consistent navigation modules, developers can create applications that are both modern and operator focused. Okay, so what is important is having to reusable objects templates, centralized in styling, alarm visualization, dynamic color behavior, response navigation structure, and there's this screen layout. Okay, let me show you here. This, for example, are a lot of valves images, right? So this is a SVG image. Our next release we will allow SV images. What is SVG is ideal for modern scale applications because it uses vector-based graphics instead of fixed pixels. This means graphics can scale to any screen size and resolutions without losing quality, keeping HMI sharp and professional on industrial panels, large displays, and web clients. So, for example, if you are using vector images, and as we have, for example, the resolution that you can use scaling, even if you have a small screen and you are going to scale to a bigger screen, that images will be the same because it's a vector image. So you don't lose quality. And then SVG also supports real-time dynamic behavior, color changes, animations, rotating equipment, alarming highlight. So this helps create cleaner and more intuitive operational interface. Okay, so this, as I said, this is going to be a new feature that we will have on our next release. Okay, so let's see more about the ISA 101. For example, these are the different colors for the same valve. Okay, so you can represent like this. It's stopped. This is running, and this is without. Okay, you can use different, or this is no operator. This is off, and this is running. Okay, so this is a kind of representative images and colors that is good for the operator see what is happening immediately. So, for example, this is on, this is off, this is inactive. All right. And the final thought is not simply about making screens look cleaner. It's about improving human interaction with industrial systems by combining ISA 101 design principles with modern engineering. Looks like this SmartView develops. Uh, Developers can create applications that are not only visually professional, but also safer, more scalable, and more effective for real-world operations. Right? Just a moment. Just a second. I need to check something.
Make sure if you have any questions, we'll start covering the other topics as well.
All right. Now I'm going to talk about the templates. The importance of templates in modern scaled applications. Templates are essential for improving productivity and standardization in modern scaled development. Instead of creating every object manually, developers can build reusable templates for equipment such as pumps, motors, valves, and tanks. Each template can include graphics, animations, alarms, scripts, and predefined behaviors. This allows engineers to build once and reuse throughout the entire application, significantly reducing engineering time and simplify maintenance. Okay? Templates also improve scalability. So makes faster to develop scaled applications, right? So let me show you how it's the best practice of using templates. First of all, I think that you need to develop a data type, right? So, for example, I have this silo, level member, volume, distance. That is the sensors is inside the silo that will uh, be used to check the volume in the data level. Okay, after that, you can create the template. For example, this template we have here an image. We have some object tags that is like the pointers. So I have this silo that is silo type and as type in the title that is a string. The title, when I put this on the screen, I will set the title that I want and the tag that is going to feed this object. So here I'm using the member using hashtag. That is how we represent the pointers, right? The object tags inside the templates. Here, for example, we also have dynamic fill. That is we use the level to fill this object, and I use a transparent background and the dynamic fill here. All right. So and then also I have this button that with the script opens the silo properties using passing also passing the real tag as parameter. That is this screen that also have the screen tags. And then here we have all the properties that you can show, and also the dynamic view. So, and then after that, you can also create your screen also with inserting the templates. The templates is the way of just click here and you see all the templates. You just choose what you want. All right. And then here, for you just set the tag that's going to feed that is the silo type and the title that you want here for your template. It's easy because you can just copy and just set another member. So you have everything here. And also if you change anything on this template, since you save it, all your application you have the new feature or the new look or depends what you made the change, right? And so let's open this silo screen. This is the silo. As you can see, we have different levels for different tags. I just use one screen for that opens this silo, and the same screen is using for this one, right? So uh, this is how you can reuse your objects and makes the easier to develop applications. And also, as you can see, if we, for example, if we come here and change the color of this object, this one, all right. If we save it, just save it and reopen that screen. As you can see, the colors already was changed for all the things. All right. So just to finish to talk about the templates. I will show you here that we have also a system templates library. And let's show you if you insert a new graph. And we go to template. We have the system templates here.
So,
I think
Leandro,
that,
I don't know
okay,
if you covered
sorry.
this, but one of the questions I got is if you are using templates throughout the application, uh, if you change something, does it change it in all the templates, or can you isolate and not change it in all of them? Do you understand the
No,
question?
yeah, yes, I understood, but like what I would do if I want to change this, for example, and I don't want this to affect all your application. You need to save as another name, for example, a silo 4. And then if you have this with your changes, and for example, it could be just change the color and something. Could be the position or the objects. Then you have this the new one, and then you would replace it. But unfortunately, it's almost impossible if you have 100 of objects. You just say no. I want this template just affect some of them, and does not because it's I don't know how would you do that, but you can
One
think
last other question I got.
if it's a really important feature, we can think how to develop this in the future.
Okay, one
Just
other question that came in
okay.
is what components can be included in template? Everything, or are there specific stuff you can't put into template?
We don't allow us to put a template inside template because it would be something different, difficult to manage. But basically, when you see a template here is basically a screen, right? What we have here, it's all these objects, all the rectangles, all the object screens, all tabs, yeah, trains. So you can create, for example, a specific template for a trend that is already have some points for a trend for 2 or 3 panes, and then you just set the panes that you want, and the trend is configured the way that you want, and so it's a template that can be used. And also charts, alarms, and everything else, you can also use templates. So there is no limitation on and using a template inside the template. Okay. Anything else about this?
No, that was all I got.
No. All right. And just to show the finish showing, I just saved the new template. So for just to answer that question. Now the silo that we changed to green is here, and then you can use it. Uh, and then, because it's easier, just configure it here. But if it's configured, if you put like a silo 0 here, and the title that you want. Uh, and then you just move to the others. So it's easy to insert a lot of templates and do your application quickly. Now you have all that easily. Sometimes you need to configure a lot of places and a lot of screens to do it in some cases. But here, if you do this architecture, you have the property already, property window with set with the format that you want, and all the this. And what is really important, you can resize it without losing. Uh, what do I say, resolution, right? You see, and that good to see it, right? Okay. So also, we said that we would talk about the user-defined data types. So it was already done here, showing you about the silo. What it was really nice in our architecture is because even here you can use a three-dimensional array, and here we allow a data type inside data types, just not the its own silo. It doesn't show here because you cannot cite a silo inside the silo, but the other ones you can use in any data type as a type inside a data type. So it's really flexible for any kind of structures that you can have in your plane, right? Um, okay. Okay, let's now. What's really nice to talk about is the 16 functions. All right, we have a huge library. I'm going to show you some of them. That is interesting. The SV applications, we have here an output that is really useful for debugging. This sends to the runtime log when you filter by user message and put as debug. Everything that if you call this message, it's going to send to the log. And here we have, for example, a function to open the data watcher. If you want to open the data watcher during the runtime, it's also possible. Opening a register license, we don't need to do it using this environment. You can do it during the runtime if you have like, just put a button. You can disconnect the viewer. So we have a huge list of things. Stop the application, set the language, send emails, so disconnect the viewer. So it's a lot of useful functions. And this allows us to make flexible applications, even on the runtime, because we can create tags document, we can create tags, we can delete tags, we can create groups, we can set bits. So we have a lot of functions to create tags. We also can create a driver document. You can also have an interface where you put the IP and everything else to create the tag connection, the driver connection that is create a channel. Here you can create the channel. In also you can create append tags on this spreadsheet. So you can also make all your communication, or even create a user function that could work as an import. That you have a CSV file that you can have the columns with all the information that you want, and then if you have all the addresses and everything for a specific equipment, as a power meter or something that has fixed addresses, not like a PLC program, but like it's all as the same address. You can create an import, and then that creates all the tags and everything, data as a data type, and then you have everything communicating with just a function that will import this from a CSV file and is connecting to equipment. And also can create a faceplate as a template to represent that equipment. So we can also have an entire template with that creates all the tags, all the addresses, and everything in one object. Okay, and easily to the developer just use this object plug and play. Okay. Just to finish it here, we have also for history, you can create and append tags to the history documents. We have also functions to create to communicate to database, create tables, update, insert. For alarms, for events, to manipulate files, and also for graphics. If you want to open, close, of course, you have buttons that does this directly using actions. But if you also want to use functions, you can. Okay. So this is our system functions, and this is our using functions. Just to show you how it is, you cannot use tags here because it's only this is C# only. If you write a service, you can write use tags, but if you just functions, C# functions users, you can't. So, but you can call another system functions and another user functions here. It's not a problem, but this is a library that you can also create today, right? Oh, I just forgot to mention something that is really nice. It's, for example, if you have if you want some SVG image, if you have a cloud, you can ask them to create some, and also as you can see here, it creates some SVG files. Let's open this one. As you can see, the green. So it's easy to create like a pretty image on an AI like cloud that's good, especially for this SVG image. So it's easy, and then you can just copy and paste in our product. Not yet, unfortunately, because in this we doesn't support SVG, but on the next version we will. So, and also we intend to send a library of SVG images that will make easier to develop applications as well, right? Okay, and now we also can talk about the triggers and the services. Here is our basically our scripts that runs on the runtime, right? We have scripts that runs on the screens. So that script runs on the viewer, but this runs on the runtime module. So the triggers, we can have a trigger that runs on an interval. For example, this is one that runs each 300 milliseconds, and it does the not for the tag. So it's used for blinking each 300 seconds. So you can create a script to runs on an interval. The options that we have is to, as a trigger, you put a tag that you can, for example, finish the batch, and the PLC sends the signal, and we get this trigger, and then we run the expression to finish something that we need to do here. It's an option. We also have the condition, so we can put an expression, and when this condition is satisfied, we run the script, and also the calendar that you can here set when you want to run the script.
Leandra, I got a question that came in.
Mhm.
How do services execute logic based on the triggers? I don't know if that makes sense to you. I'm not.
Okay, yes, yes. You also can change here for services. You can, because here could you work as the same, but here it shows the services, and you can run the services or an expression. The expression is just this script, and the service is like that. So you can call the services on the trigger. It's integrated, and also for the here. You have the condition in a trigger, so it just on here you also can put a trigger and do this directly here. We have like some redundancy way to do the same thing, but these are the options. Okay, this answers the question.
They said yes, you did. Okay.
All right. So we already covered about the architecture, the templates, the data types, the graphics screens, the system functions, the triggers and service. And I'm going to talk quickly about the rule-based system, and then I'll be open for questions, right? Just find another application to show the. Here is an application that shows the rule-based system with basic rules and advanced rules. So as you can see here, this is a rule. This is for a way to see how you can do easily a visual logic, and it's perfect for getting operator knowledge that it's how he respond for each event or something, and then you can create visually something to solve that and answer instead he having to do something. you get all the knowledge that it could be a condition. For example, the temperature is higher of something, he needs to do something there. So, and also we have logical operators, and then you can create a bunch of these rules and also create more these advanced charts with the rules and conditions. Uh, this and create the whole flow chart and from the rules, the conditions, and the logic operators, the actions that you want to do. That could be nothing or set a tag, run a script, send an email, or create an event. So easily you can pass all this information from the operator visually to a logical tree, and then a logical flow chart, right? And then it's easier to match with the way that the answers for each event or if in each condition. And also it's easy to change if something changes how is the way that it wants to respond of that event. You don't have to go to all the service on the scripts and say no, now I have to do. You have visually just the logicals and just the errors and set the new behavior for that condition, right? So let me just run this one. Hope this run because a lot of time that I don't run. For example, now we have this. If you see, uh, the idea is passed to all the paths to reach the end. Okay, but if something happens here, you see that it's changed the logic to do another way. And also, if you have it here, change the logic to pass through most of them. All right. And how it works. This we have this whole flow chart that represents the paths, and based on the logics, does another path, and then you have the intelligence to make the decisions based on the events that could change what you need to do. All right. So I think that I already covered all the agenda, and now I'm open to answer questions.
Okay, I've got a couple questions that came in, and please, everybody, either use the chat or you can WhatsApp me the questions. Here's one that came in. How can JSON export be used in real applications?
JSON?
Mm-hmm.
Yes, unfortunately, we don't import or export JSON files yet, but I think that we can think about doing this. We just export and import CSV files now for the tags and have all the data types or something. All right.
I think it's
But
actually about exporting, not importing, but is it the same? I don't
yes,
know.
yes, the same. Yeah, we don't export it yet, but
Okay.
you can easily create a user function even now using AI, ChatGPT or something to help you to create a function, a user function that you can export as create to export the data that you want to a JSON file that can be an import to another system, for example. And also we have the driver that is a REST API, that is the web API, that is REST that basically communicate through using the JSON uh, format to exchange data between systems. Okay, this answer the
Okay,
question.
and then there's another one that came in. What file handling capabilities are available? I think it's a very similar
Sorry?
question. What FILE, handling capabilities are available? I don't know how
To
you would even
export,
get, I
to
guess
export.
they don't have,
Yeah, it's just CSV files. That is the text one.
okay.
Yeah.
And then there was another questions about how do facts in the rule-based system work? Uh, The facts.
The facts. The facts. The facts are assertions or anything that is relevant to beginning state of the system. Okay, it's not mandatory, but the facts it's like a database of information. It's not the database, but let's show you the kind of facts that we have. For example, if you use a database as a source of this fact, you just choose the connection that you have. Yeah, my connection will be because my SQL is not set properly, but here would be show all the tables that you have there. All right, and then you can use a table as a cert as a fact for for a fact. Yeah, is a and let me just change something here and then show you better because this was not my presentation. This is the window problems, not the okay. And now I think that okay, maybe here. We have like this data. Now you have all the columns, right? And imagine it, okay? Name it A, no, BB, all right? And then if you have this fact, you can use like any DB dot each column, and then use that as an insertion to your rules. And then if you are using that fact, for example, if you're using a column, it's going to check your entire column when you run that rule. So it can find any abnormal value, an alarm or something. So it makes it's in a way to have a scenario to make decisions over that scenario or over that column or something. And also could be an SV file that also you have all the columns as a member of that fact. And you can use an array of tags to represent a fact. So it's a source of the rules, basically, that can be database columns, CSV files, and tag arrays. Okay.
Another question came in about what is a generic screen and how is it used?
Okay, let's back to the silo. Oh, I need to stop it here and come back to that application. Just a moment. As I said before, we have these screen tags. You can create many of them. You can set this a data type. You can set this a regular tag, or it could be a generic. And then we use hashtag because here in our product, on the screens, on anywhere, if you want to address something like in the test, you use a tag, use at second, then it's going to be fixed to a tag. If you use a pointer or a screen tag, this is going to work as a pointer. So if you use a hashtag, we don't have this tag inside of property created. It doesn't count as a tag. It's just a pointer. In this case, it points to a member of this data type. That is the volume member. So with that, we can create a generic screen. That's a generic for that object, not generic for any object. Generic for just the silos, because you are using the data type to feed it. So with that, you don't need to create and use different indexes and or set different tags and have a lot of the same tag saved with a lot of names, different names to address the different tags. You just create this that can be a generic screen or a generic for data types or single tags. But you can reuse this screen any place and also on another application. Okay, does this answer the question?
I think it does, yeah. So I didn't receive any other questions. Does anybody else have any questions before we close? You can either put it in the WhatsApp to me or chat, whichever is best for you. Are there any last minute questions? Okay, I didn't receive any. Thank you so much, Leandro, for your time doing this
Okay,
presentation.
thank
Thank you,
you.
everyone, for attending. We really appreciate it. Please send us questions along the way. We really love hearing from you guys. Either send it to info@adisra.com or directly to each of us because we want to hear from you. Thank you very much and have a wonderful evening, day. Thank you.
Thank you.